Dear students, welcome back to my channel. In this class, let us discuss about an expression for electric potential at a point due to an electric dipole. So it is an important 5-mark derivation. So you will get that question in your annual examination or in an examination like this. Derive an expression for electric potential at a point due to an electric dipole. What do you mean by an electric dipole? Yes, two equal and opposite charges separated by a small distance is said to form an electric dipole. Similarly, what do you know about electric potential? Electric potential at a point in an electric field is the amount of work done in moving a unit positive test charge from infinity to that point against the electric field direction, isn't it? Okay, now let us try to derive the expression for electric potential. So in case of two equal and opposite charges, in your last class or previous class, we have discussed about electric potential at a point due to an isolated point charge, isn't it? And what we have got there? V is equal to 1 upon 4 pi epsilon naught q divided by small r, isn't it? That equation we have derived. But in this class, let us derive the same electric potential, but in case of two equal and opposite charges, that is none other than electric dipole. Okay, see. Let us consider an electric dipole containing two equal and opposite charges, that is minus q and plus q. Let A be the point at which minus q has been placed. Similarly, at point B, plus q charge has been placed. Now, let O be the center of this electric dipole. Let small a be the distance between center and the charge, any one of the charge. I will write here. If it is A, then it is also A, isn't it? Therefore, two equal and opposite charges separated by a small distance is said to form an electric dipole. So, in case of an electric dipole, it is mandatory to write the direction of electric dipole moment, that is small p, which is always from negative charge to positive charge. Now, say for example, P be a point at which we want to find out the electric potential. So, which is at a distance of some small r from the center of the dipole. Okay. Similarly, let us consider BP is the distance between the point and the positive charge. You can call this as R1. Similarly here, you can call this distance as R2. Actually, we won't use these R1 and R2 in our derivation, but it is not mandatory to write R1 and R2. Okay. Next, first, at point P, since there are two electric charges, we can expect two electric potentials, isn't it? Therefore, I will start my derivation here. From here, electric potential at P due to the charge at A is electric potential at P due to the charge at A. What type of charge is there at A? Minus Q. Therefore, it is given by VA is equal to 1 by 4 pi epsilon naught. What type of charge is there? Minus Q. Minus Q divided by, what is this distance? You can call it as R2, otherwise simply AP. Similarly, VB is equal to 1 by 4 pi epsilon naught. What type of charge is here? Plus Q. Plus Q divided by BP. See, this is not a perpendicular line. Okay. Next, what is the net potential at P? Therefore, the net potential at P is V is equal to VA plus VB. We know that electric potential due to positive charge is positive, electric potential due to a negative charge is negative. Therefore, V is equal to VA plus VB. What we can take common in VA and VB? That is Q divided by 4 pi epsilon naught. We can take common. We can take outside. So what remains? I will write BP first, minus of 1 divided by AP. Isn't it? Now, what are the values of BP and AP in terms of R? Okay, I think it will confuse you. Therefore, I will rub this. Now tell me, what is the value of AP and BP? How to find the value of AP and BP? For that, what we will do means, I will extend this line up to this point. Next, I will write a perpendicular. I will draw a perpendicular and I will call this point as some M. So this is angle 90 degree. It is making some angle theta. If this is theta, this is also theta because vertically opposite angles. Similarly, I will draw one more perpendicular from point B to this line OP. Okay. So I will call this point as some N. Here the angle is same 90 degree. Okay. Now, see, let AM is the perpendicular drawn from A to OP produced. A to OP produced. And BM is the perpendicular drawn from B to OP. Isn't it? So we are considering them like this. Let AM be the perpendicular. Let AM be the perpendicular drawn from A to this line OP or PO produced. Better to write PO produced. Similarly, BN is the another perpendicular drawn from point B to this line OP. So BN is the perpendicular drawn from B to OP. Therefore, see, AP is approximately equal to MP. Isn't it? AP is approximately equal to MP. Similarly, otherwise and. See, this PN is approximately equal to BN. PN is approximately equal to BP. Isn't it? NP or PN approximately equal to BP. Now, what we can substitute in place of BP and AP? How to know the value of BP and AP in terms of small r? Means, see, in case of AP is what? MP, isn't it? See, from figure, for my reference, I will take this as equation number 1. From figure, that AP is approximately equal to MP. AP is approximately equal to MP. But what is the value of MP? MP means MO plus OP. MO plus OP. What is the value of MO? We don't know. For that, what we will do means, here I will write, from triangle AMO. From triangle AMO, we need this side, isn't it? This side is adjacent side. This is opposite side. It is an imaginary line. Therefore, adjacent is the real one here. Next, adjacent comes in cos theta. Therefore, from triangle AMO, cos theta is equal to adjacent by hypotenuse MO divided by AO. That is, MO value is A. MO divided by A. Therefore, MO is equal to A cos theta. Put this MO value here. That is A cos theta plus, what is the value of OP? OP value is R. Otherwise, we can also write like this, R plus A cos theta. So this is AP value. Similarly, we want to find out BP. Similarly, BP will be, no need to show all these things again. For BP, you write R minus A cos theta. Similarly, BP is equal to R minus A cos theta. Substitute these two here. What we get? Okay. V is equal to Q divided by 4 pi epsilon naught 1 upon BP R minus A cos theta minus 1 divided by R plus A cos theta. Cross multiplication gives you Q divided by 4 pi epsilon naught R plus A cos theta minus R, minus into minus plus A cos theta divided by, see, it is A minus B into A plus B. Okay. It is A minus B and it is A plus B. In the next step, we can cancel R and R. A cos theta plus A cos theta. What you get? Yes, 2A cos theta upon A minus B into A plus B is A square minus B square. Therefore, R square minus A square cos square theta. Next, Q into 2A is what? That is the product of any one of the charge forming the electric dipole, and the distance between two charges is called electric dipole moment. Therefore, it is 1 divided by 4 pi epsilon naught. Q into 2A is P cos theta divided by R square minus A square cos square theta. So this is the expression for electric potential at a point due to an electric dipole. Please remember, I will repeat once again an important derivation. Please see here. In the question, they are saying to find, they are asking to find as to find out electric potential at a point due to an electric dipole. Therefore, I have taken one electric dipole, minus Q and plus Q, two charges, equal and opposite charges. I have placed them at A and B respectively. So, and we are all doing this inside vacuum. Next, let O be the center of this electric dipole. From center, at a distance of some smaller, I have considered here. It is better to write OP is equal to R. Otherwise, you can show the arrow mark like this. From O to P, I have taken small r like that. Okay. Now, at distance smaller from center O, I have considered a point P. Next, at P, how many electric potentials we can expect means two electric potentials. potentials we can expect, because here are two electric charges. One is negative charge, another one is positive charge. The potential at P due to this negative charge is negative. The potential at P due to this positive charge is positive. So that is our actual what agenda here. Electric potential at P due to the charge at A. I have started from there. At A is given by VA is equal to 1 by 4 pi epsilon naught minus Q divided by AP, because at A we are having minus Q before, minus Q divided by AP. I have wrote. Similarly, electric potential at P due to the charge at B is given by 1 by 4 pi epsilon naught plus Q divided by dP. Hagadre, what is the total potential? Just we have to add them. So according to superposition principle, the net electric potential is equal to the algebraic sum of electric potentials, individual electric potentials. Therefore, V is equal to VA plus VB. I have to put Q divided by 4 pi epsilon naught outside, and I wrote the remaining thing, 1 upon BP minus 1 upon AP. So you can call it as equation number 1, otherwise no need to call it, because I haven't used the word from equation 1 anywhere. Therefore, okay. Now, it is our duty and our responsibility to find BP and AP in terms of this R. For that, what I have wrote here means, I have considered AM as the perpendicular drawn from A to this line PO produced. Similarly, BN is the perpendicular drawn from B to this line PO. I have considered. Therefore, AP is approximately equal to MP. Similarly, NP is approximately equal to BP. Next, okay, come here. From figure, AP is approximately equal to MP. The value of MP, M to P, is nothing but MO plus OP. MO plus OP. We don't know the value of MO. Therefore, what I have did means, I have taken this triangle AMO into consideration. Here, cos theta is equal to adjacent by hypotenuse, MO divided by A. Therefore, MO is equal to A cos theta. Similarly, okay, write the value of MO here, A cos theta, and hence AP is equal to R plus A cos theta. Similarly, if we consider this triangle ONB, and if we take cos theta, then adjacent by hypotenuse and all, what we get here is BP is equal to R minus A cos theta. Okay, next substitute their values and simplify to get finally this equation. Next, in place of Q into 2A, I have considered small p. Okay, so this is the expression for electric potential at a point due to an electric dipole. Okay, very important question for 5 marks. Okay, now let us discuss few special cases here. Here are two special cases. Special cases. Case number 1. If the point P lies on the axial line. What is the angle theta? Yes, you should know that theta is equal to 0 for axial line. Therefore, V axial will become 1 by 4 pi epsilon naught. What is cos 0? Cos 0 is 1. Here cos 0 is 1. Therefore, it is simply, okay, no problem, I will write P cos 0 divided by R square minus A square cos square 0. Cos 0 and cos square 0 are 1. Therefore, V axial is equal to 1 over 4 pi epsilon naught P over R square minus A square for any electric dipole. For a short dipole, you know that A is very much less than R. Therefore, R square minus A square is approximately equal to R square only. Therefore, V axial will become 1 upon 4 pi epsilon naught P over R square. This is the expression for electric potential due to a short dipole on the if the point lies on axial line. Similarly, the second case, very interesting case, if the point P lies on equatorial line, what is theta? 90 degree. Okay. If you put 90 degree in the numerator, cos 90 will become 0. Therefore, V equatorial is equal to 0. An important question for 1 mark. Please remember, the value of electric potential at a point on the equatorial line of an electric dipole is a big 0. Okay. Anyhow, it is, as I said earlier, it is a very important 5-mark derivation. So please solve at least, derive it at least 2 to 3 times. Okay. Thanks for watching. In my next video, I am going to cover about equipotential surfaces. Equipotential surfaces. Surfaces are having equal potential. Okay. Thanks for watching.